Hey guys, welcome back. Today we're going to be covering Review B from your Algebra 2 book. There's, again, about 5 concepts that are going to be covered in this review. Again, we're going over these because you really should have already learned them over the last 4 years. We're just making sure that we remember all these things before we dive into some of the more complex concepts within this lesson. So here we go. First part we're going to talk about is perimeter and circumference. Both do the same job. One is just dealing with circles and the other one is dealing with everything else. Perimeter and circumference is just measuring the measurement around something. It's just the border. So if you are imagining this being your yard, you would be measuring the fence going around your yard, not the space within your yard. So a quick example right here. It's just got 4 sides, it's a polygon, and the way you find the perimeter is you just add 4 of them together, slap on your unit of measurement, and you're done. This one has a little bit more terminology, so we're going to go over this just a little bit more. Terms that you need to know when dealing with a circle. A radius is this little guy right here. Usually it's indicated with a lowercase r. And what that is that's a measurement from anywhere on the border of the circle going right to the center. That is the radius. Another term is a chord. A chord is a line that runs through the circle and it just goes from one part of a circle to another on the outside and just crosses through the inner part of the circle. A very specific chord is our diameter. And our diameter is very special because it is a chord and it is to radius. It is a straight line that runs through the center of the circle, creating a straight line through the center of the circle. So it's 2 radiuses, and that is often indicated with an uppercase D. And so that is the diameter. Diameter D equals 2r. Diameter will always equal 2 radius. And our formula for finding the circumference, the measurement of the outside of this circle, is either pi d, or you can say 2 pi r, because 2r is the same as saying diameter. So you can say either one of those. In this case, to solve the circumference, the only thing we need to know is the radius. If we know the radius, we can find the diameter. If we know the diameter, we can find the radius, either one, and both of those, I just need one of them and I can solve because the other number we're dealing with is pi. And so that's all there is to perimeter. Okay, so the next concept we're going to talk about is area. Perimeter measures the outer part. Area measures what is inside that certain object, that shape. And so just looking at this is just going to be one of our practice problems that we do, but it's going to want us to find the area within this shape. Looking at this, there isn't a set formula for this particular shape, but what I can do is I can split this up into 3 shapes that I do know how to work with. So what we're going to do is we're going to split this right here, and now we have a triangle here, and we're going to split this right here, and this creates a semicircle and a rectangle, and all of these are right angles. So I'm just going to go ahead and write it like that so we know. So now I have made this a much more manageable shape that we can deal with. I'm going to label these just so I can keep my formulas straight. I'm going to call this part A, part B, and part C. Now, for me, I like to do all of my setup first and then plug in the numbers that they have given me. I want to get as much of the groundwork done first. So I'm looking at shape A, and I notice it kind of looks like a circle, but it's not a whole circle. It's half a circle. So I'm going to remember or look up in the back of my book the formula for area of a circle. That is pi r squared. But this isn't a whole circle. It's half a circle. So I'm going to divide by 2. That is how we find the area of a semicircle. We divide by 2. The next part is B. This is a rectangle. Formula for area of a rectangle, length times width. Okay, and then for part C, this is a triangle. Formula for area of a triangle is base times height divided by 2. Okay, so now I have all of my formulas. I just need to replace all of these variables with numbers, and then we can do some multiplying and adding, and then we're done. So looking at part A, the only variable I have for part A is the radius. Our radius is 2, so I'm going to go ahead and write that in. Okay, the next part, for part B, I need my length and my width. So I see I have 2 options here to choose from. I have 4 and I have 7. I'm going to go with 4 because I'm only looking for this part. And 7 does not refer to just shape B, it refers to this whole line, and that includes C. I don't need that measurement, so that's why I'm going to choose 4 for my length. And now I need to find my width. This problem does not automatically tell me what our width is, but it does give me some hints. I know that this radius is 2, and I also know that while we're seeing it here, I also know that this part is 2, and this part is 2, and 2 plus 2 is 4. So we know that the height, the width of this shape is going to be 4. Okay, last shape, part C. We're dealing with a triangle, base times height divided by 2. We know what our height is, we just found it. So I'm going to go ahead and plug that in. We don't know what our base is though. We know that this part is 4, we know this whole thing is 7, so we can subtract and know that this part is 3. Okay, so now I have all of the numbers needed, and now we're just doing a little bit of multiplication. So 2 squared is 4 divided by 2. This is going to be 2 pi. This is going to be 16. And then 3 times 4 is 12 divided by 2 is 6. And then we're going to add all of this together. So we got 6 and 16 is going to be 22 plus 2 pi. We can't add these two together unless we are going to multiply 2 pi out. But as long as we're going to leave it as 2 pi, we have to leave these as separate. And then the last step is I need to include my unit of measurement. So it's going to be meters, and since we are dealing with area, it is going to be squared because this is a 2-dimensional object. The exponent is going to be 2. And that is done. We put this whole answer in parentheses because meter squared does not just get applied to the 2 pi, it gets applied to the 22 as well. So we have to put this whole part in parentheses. And that is how we find the area of a very interesting shape. Our next example is very similar in concept as there are multiple shapes that we'll have to find the area for. But in this case, this example wants us to find the area of the shaded region. So notice in this part, yes, we're dealing with a very large rectangle, and I could just do length times width and be done, but that's not what the question is asking for because the circle and the triangle are not shaded. So we're going to need to find the area of this big triangle and then subtract the area of the circle and the area of the triangle. So we're going to work with our big part first. That's pretty simple. So it's length times width. We'll call this part A. And then we'll call this B and C. And these parts are going to be subtracted. So for part A, we have length times width. For part B, we're just dealing with area of a plain circle, so pi r squared. And then for C, we're dealing with a triangle, base times height divided by 2. Okay, and now we're just going to plug in all of our numbers. Length times width, we have 10 times 15, and then we have pi 4 squared, and then we have 6 times 5 divided by 2. Notice up until this point, we haven't really had to do any difficult mathing. If we take our time and we set up the whole problem and we get all of these values plugged in and then we start to math, it doesn't look as intimidating. But if you try to do it all in one big step, it can be a little overwhelming. That's why I like to take my time, set it up, get everything plugged in, and then solve. So first we need to find this. We know that this is 150. And then I'm going to block that off because I have to remind myself these two are not being added to it, they're being subtracted. So this is going to be 4 times 4 is 16, so 16 pi, and then 6 times 5 is 30, divided by 2 is 15. Okay, so we have 150 minus 16 pi and 15. Okay, and this we can enter into our calculator. And as I type this into my calculator, I am typing it in exactly as I have it written. So I'm going to say 150 minus, and then open parentheses because I wanted to subtract this whole thing, and parentheses matter. All right, and when I finish, it's going to give me a very long decimal, and I am just going to round to 2 decimal places. So it's 84.73, and we got to include our unit of measurement, so meters squared, and that's it. We are done. Now let's take a look at volume. Volume cannot be addressed until you have first learned area. Volume is dealing with 3-dimensional, so it's taking the area and including height. So you've got to remember everything that we just learned about area, because it's going to come back into play here. Where the area of a rectangle is length times width, the volume is going to be length times width times height, because it's 3 dimensions. And notice also we have 3 variables, and we're multiplying. That's why it's called 3D, 3-dimensional, is because there are 3 different measurements being multiplied in here, not added, multiplied, and that's where we get that. So another way that you can look at this, because it's not always going to be rectangles and rectangular prisms and cubes that we're dealing with, sometimes length times width won't be an accurate description. So a more basic formula that we can do that will apply to everything, regardless of whether you're dealing with circles, semicircles, triangles, rectangles, and all other types of strange shapes like pentagons and octagons, is if you were to say instead area of the base times the height. Area of the base is the same thing as saying length times width. It's the area. But this is more encompassing of other types of shapes as well. And so that's why I prefer to work with this definition, because sometimes we'll be dealing with a cone, or we'll be dealing with a circular cylinder, or we'll be dealing with a pyramid. And with cones and pyramids, there's an extra step with your formula, but you get the point that this is going to help us out a lot more. Okay, so let's say we are dealing with this shape. We have already found our area. It was 22 plus 2 pi meters squared. Okay, same shape, but now they are giving it a height of 3. All I'm going to do is take this measurement and multiply it by my height. And in this case, I'm still going to leave pi as pi, so I'm going to distribute the 3. So it's going to be 66 plus 6 pi. And my unit is going to change. Instead of meters squared, it is now going to be meters cubed, because we're dealing with volume. Volume is 3-dimensional. 3, so my exponent is 3. And this is how you find the volume. Okay, so now let's look at how do we find the volume for a cone. It is going to be a little bit different, just because a cone is not like a right cylinder. When it goes up, it goes to a point. And so part of this is going to get shaved off. That's why we're still going to use area of the base times the height, but we're also going to be multiplying it by 1/3 because it cuts in. So what I love about this example that your book gives you, example B4, is they already tell you the area of the base. Because this is a really weird base. It would take a lot of cutting and pasting to find all these different pieces of the area and add it all together. So in this case, they just tell you the area of the base is 242 meters squared. And so all we're going to do is plug this in here, and it tells us that our height is 10. So we'll plug that in there, and then we'll just solve. And that is all there is to it. So we multiply this out, and I'm going to use my calculator for this part. And we get 806.67 meters, 3-dimensional, so it is cubed. And we had just found the volume of this cone. Okay, last part in talking about volume is, let's find the volume of a sphere. Great thing about a sphere is all you need to know is the radius. We don't really care about anything else. As long as you know this formula and you have it on your formula page, you're good to go. So let's say we had a radius of 3. So I'm going to replace r with 3. So we have 4 over 3 pi times 3 cubed 3 cubed is 27, so we have 4 times 27 pi over 3. That reduces, so we have 36 pi, and I'm just making this up, meters cubed. And that's all there is to it. So all you need to know is your radius and your formula. The next concept in this lesson is surface area, meaning the area of all the surfaces of a three-dimensional object. Here we have a triangular prism. It has 5 sides. It has the front and the back, the bottom, the side, and the slant. So when I am looking for the surface area of this triangular prism, I should be finding the area of 5 different sides, and then I'm going to add them all together. Now that is very tedious in my opinion, so I'm actually going to share with you guys a different formula rather than finding all 5 of these areas. There is a certain formula that you can use, and it will apply to multiple shaped bases, not just triangles. It works for cubes, it works for cylinders, and things like that. So that is what we are going to focus on. So I'm going to write it on the board. Okay, so the formula that we use is going to be 2 times the area of the base plus the perimeter of the base times the height. Now in this case, I am going to, in my mind, flip this up where the triangle is on the bottom. So 2 times area of the base, my area of my base is a triangle. So I'm going to find the area of the triangle and multiply it by 2. So looking at this triangle, I see that my base is 3 and my height is 4. So we're first going to replace all of this with formulas. Okay, and instead of perimeter of base, I'm just going to add the perimeter of the triangle. So I'm going to go ahead and leave it like that. And now we're going to start plugging in numbers. Instead of B, I'm going to write 3. And instead of H, I'm going to put 4. Plus, for perimeter, we have 4, 3, and this number. And while it's not labeled here, it is labeled right here where the measurement is 5. Times the height, and in this case, it's going to be 6. So now we are dealing with just a bunch of really small numbers. We're going to multiply it out. 3 times 4 is 12, divided by 2 is 6, times 2 again, so it is back to 12. Plus 4 plus 5 plus 3 is 12, times 6 is 72, equals 84, and we are dealing with meters squared. Okay, and if you don't believe that that works, go ahead and fact check me. I challenge you. Find the area of all 5 sides of this triangular prism, add them up together, and you'll get 84 meters squared. But we just saved ourselves a ton of time, and that's how you find the surface area. Now let's find the surface area of a cylinder. We're going to stick with our formula, 2 times area of the base plus the perimeter of the base times the height. In this case, our base is a circle, so formula for area of a circle is pi r squared. I'm just going to rewrite this formula first. 2 times pi r squared plus the perimeter of our circle. Now for circles, we don't say perimeter, we say circumference. So I'm going to use the formula for circumference, which is going to be pi d, or I could say 2 pi r, either one, and it's going to be multiplied by the height of my shape. So now that we have all of our formulas plugged in, we're just going to replace our variables with numbers. So we have 2 times pi, and then in place of r, I'm going to write 4 squared. Plus, notice I'm taking my time with my parentheses because I don't want the square to be on the outside of this set. The square is only being applied to the 4. And then also we have pi, and instead of diameter, I'm going to say 8 because the radius is 4 and 2 times 4 is 8. Times our height, which is 10. Okay, so I have no letters left, just numbers and pi. So we got 4 times 4 is 16, times 2 is 32 pi, plus 8 times 10 is 80 pi. And that is going to equal 112 pi. And then our unit measurement is meters. And we are dealing with surface area, so that's 2-dimensional, so squared. And that is it. We are all done finding the surface area of a cylinder. Okay, the last one we're going to do with surface area is we're going to talk about finding the surface area of a sphere. Now this is just a circle, it's not an actual sphere, but I'm not very good at drawing spheres, so this is the best we're going to do right now. it is the only one that has a different formula than what we have been working with. This one is going to be 4 pi r squared. And all you need to know is your radius. So we're just going to replace r with 8 and solve. So we have 4 pi 8 squared. 8 squared is 64. Okay, and off the top of my head, I don't know what 64 times 4 is, so I try to keep other things in my brain than that. So it's 256 pi centimeters, and we're still dealing with surface area, so it's going to be squared. And we just found the surface area of a sphere. Our last concept that we're going to be covering in this lesson is going to be finding the area of sectors of a circle. So here we have a circle, and the sector that we're focusing on is 27 degrees and has a radius of 6. So we're still going to work with the formula for area of a circle, which will be pi r squared, but this is for a whole circle. We're not dealing with a whole circle. We're only dealing with 27 degrees of it. So we are going to multiply this whole thing by 27 over what is a full circle, 360 degrees. So this is going to be our formula for finding area of a sector. And so all we need to know is our radius, and then in this case, we also need to know the degree of the angle. So we already know it's 27 over 360 times pi, replacing r with 6, squared. And then I'm not going to do that math by myself. I'm going to leave pi as pi, but I'm going to do the rest of the math in my calculator. 27 divided by 360 is 0.075, and then times 36. So this is going to be 2.7 pi centimeters squared. And that is how you find the area of the sector. So let's do some practice. So now we're going to find the area of this sector. We have 45 degrees for our central angle, and we have a radius of 10. So we're going to still be using pi r squared, but we're going to be multiplying it by just that part of the sector of the circle that we need. So 45 over 360, we're going to replace r with our radius of 10. And 10 squared is 100. So 4,500 over 360 pi, and we're going to use our calculator to simplify it. And this will be 12.5 pi meters squared. And we have just found the area of this sector. For this next example, let's say that we're still using the same circle, but this time they don't want to know the area of this sector, they just want to know this length of the circumference. We're going to take the same concept that we've been using to find area of a sector, and we're going to apply it to finding the circumference of a sector. So we're still going to work with our formula for circumference, which is 2 pi r. And then instead, but this is dealing with the whole circle, and we don't want the whole circle, we just want the 45 degrees of it. So we're going to multiply it by 45 over 360. Okay, and now we're going to replace r with 10. So we have 2 pi 10 times 45 over 360. And 2 times 10 is 20, times 45 is going to be 900 over 360. I probably could do it on the board, but let's just go ahead and make sure we get this right. So 2.5 pi meters, and it's just meters because we are dealing with circumference. So it's not going to be squared, it's not going to be cubed, it's just meters. And that's how you find the circumference of a sector of a circle. Well, that's it for this lesson. I hope this was a great refresher for you guys with these 2 lessons, and this is just going to help us do really well with this school year. So we want to put this on YouTube, that way you guys can continue to reference these in case you find yourself needing a refresher. This will be here for you guys all year long.